Hey everyone, welcome back. We have a semicircle resting on a horizontal diameter. The two endpoints of the diameter are A and B. Inside the semicircle, point E lies on the diameter. A line segment goes from E up to a point D on the arc. From D, another segment reaches a second point on the arc, point C. Now, let's list the information we're given. Segment AE is 7 units. Segment DE is 21 units. Segment CD is 16 units. And most importantly, angle CDE is exactly 90 degrees. Our goal is to find the radius of the semicircle. Let's solve it one step at a time. Right now, working with only a semicircle feels a little awkward. So let's make one simple construction. Complete the other half of the circle. Now extend segment DE straight downward until it meets the lower arc at a new point, F. Let's call the small segment EF lowercase x. Next, let the radius of the circle be lowercase r. That means the entire diameter, AB, is 2r. Since AE is 7, the remaining part of the diameter, EB, must be 2r minus 7. Now we can use the intersecting chords theorem. The horizontal diameter AB and the vertical segment DF intersect at point E. So the product of the two horizontal pieces equals the product of the two vertical pieces. That gives us 7 multiplied by the quantity 2r minus 7 equals 21 multiplied by x. Let's simplify. Divide both sides by 7. We get 2r minus 7 equals 3x. Now add 7 to both sides. So 2r equals 3x plus 7. Keep that equation in mind. We're about to use it. Now comes the geometric breakthrough. Notice that angle CDF is a right angle. According to Thales' theorem, whenever an angle on a circle is 90 degrees, the side opposite that angle must be a diameter. So, if we join points C and F, segment CF is a diameter. Its length is 2r. That gives us a right triangle. Triangle CDF. Its 3 sides are easy to identify. One leg is 16, the other leg is 21 plus x, and the hypotenuse is the diameter, 2r. Using the Pythagorean theorem, 16 squared plus the quantity 21 plus x squared equals the quantity 2r squared. But wait, we already know that 2r equals 3x plus 7, so let's substitute that. Our equation becomes 16 squared plus the quantity 21 plus x squared equals the quantity 3x plus 7 squared. And now comes the most satisfying part of the entire puzzle. Let's expand both sides. On the left, 16 squared is 256, and the quantity 21 plus x squared becomes x squared plus 42x plus 441. Adding those together gives x squared plus 42x plus 697. Now expand the right side. The quantity 3x plus 7 squared becomes 9x squared plus 42x plus 49. Do you see it? The positive 42x appears on both sides. They cancel out completely. No messy quadratic equation. No quadratic formula. Just clean algebra. We're left with 8x squared equals 648. Divide both sides by 8. X squared equals 81. Since x represents a length, x equals 9. Now for the grand finale. We already found that 2r equals 3x plus 7. Substitute x equals 9. 2r equals 3 times 9 plus 7. That's 27 plus 7, which equals 34. So the diameter is 34, and the radius is 17 units. That's our final answer. The radius of the semicircle is exactly 17 units. If you enjoyed today's challenge, don't forget to like the video, subscribe for more beautiful geometry puzzles, and I'll see you in the next one.